Okay, today's lesson, demonstration, is going to be on the table saw. Table saw is the cornerstone in any shop. It does the most kinds of things, probably responsible for the most injuries. But you can do so much with a table saw. So we want to go over the basics today of how to cross cut, how to rip, how to change a blade, and basic parts of the machine, and just kind of takes you through some of the basic operations of the table saw. There's lots of joinery techniques that can be done on a table saw. No way can I do them all at once. There's just so many possibilities. But we're going to go through some of the basics right now so you have a good general understanding. We have here a saw stop table saw, which is really nice. This is the kind of saw that senses if you're touching the blade and throws a break. This is not a commercial for saw stop, but I am very happy that we have this machine. It makes life a lot safer. It's well worth the investment, in my opinion, to have a machine like this, even though there's a higher cost to it. It also, the reason I mention it is because there's a brake mechanism that you'll see in this that has to get changed when you change blades, that a regular table saw will not have. And the power setup on this is a little different as well. But here we go. All right, so again, table saw can do a million things. It can make cross cuts, rips, and different kinds of joinery. The thing it cannot do, and you should not attempt to do, is to cut a curve with a table saw. That's what causes injuries and problems and issues. All right. So basically, again, we're using a handout here that I prepared that has all the basic information on it. If you're a student of mine, you should have a copy of this that you're looking at as we go through this. The purpose of the machine is straight cuts on surfaced lumber. People cut rough lumber on a table saw all the time, but there are much safer places to make straight cuts on rough lumber because rough lumber doesn't lay flat. It's irregular and it could wiggle, and when something wiggles while it's being cut on a table saw, that's when accidents happen and kickbacks happen. Okay, bandsaw is probably a much better choice for cutting rough lumber. Radial arm saw is even not that bad for cutting rough lumber, but we want to be cutting surfaced lumber that will lay flat on the table all the time. So straight cuts on surfaced boards for cross-cutting and ripping, and like I said, an assortment of joinery. Okay, you need at least one good face and one good edge when using the table saw. Good face is going to sit on the table most of the time, and the good edge is either going to go against the fence or against the miter gauge. So that's the minimum that you need for cutting on the table saw, in my opinion. Table saws come in different sizes. This is considered a cabinet saw, where the saw itself goes right to the floor. Typically, it's kind of the thing you see in a cabinet shop. Typically not a home type of saw. Then you have two other kind of breakdown size-wise, what they call a contractor saw. The saw is about this tall, goes to about here. It sits on a stand, and it usually has the motor hanging out the back that's driven by a pulley. And then the next smaller size, which is real common, is like a benchtop saw. And again, they often come with stands of various kinds, but it's pretty portable. You can put it in a pickup truck real easy, bring it to a job site. Very easy to move around. Usually the motor and the shaft that the blade is attached to, the arbor, is one and the same. So that kind of limits the size of the motor and the horsepower that you can have. So those little portable saws are great, but again, they are limited on horsepower. On this style saw, the cabinet saw, or even a contractor saw, you're going to have a much bigger motor because the motor is down inside the machine or hanging out the back and can be fairly big, and then there's a belt that comes up to the arbor to drive the saw blade, so you can have a larger saw. But typically, though, they're sized by the largest diameter blade that will fit. This is a 10-inch table saw, so the biggest diameter blade that will fit this machine is 10 inches in diameter. My little portable saw that I have at home with this little teeny motor, that's still a 10-inch saw. I can still put a 10-inch blade on it, just again, less horsepower. But 10-inch table saw, it's a maximum diameter blade. And they call that an indirect drive or a direct drive. This is an indirect drive because the motor is positioned somewhere else and powered by a belt. Direct drives are the small benchtop type saws that you have, and you'll see that on the handle. And then, of course, there's the basic parts on a table saw. You have the table, of course, that you put everything onto. It has two grooves in it for the miter gauge to fit into. The fence, which attaches to the table for cutting with the grain, rip cuts. We have a miter gauge that would fit into the saw. This one is stored on the front here. Miter gauge fits in the slot and is for cross-cutting a board. Okay. we have the, let's see, some of these other things are not on here yet. I'll talk about those in a second as far as the guard goes. Parts in the front of the machine, we have the hand wheel, which raises and lowers the blade. It has got a little locking knob in the front, so before you make an adjustment, loosen that just a little bit. And when I turn this, you can see the blade going up and down. Okay. On the side of the machine is a very similar wheel. We call that the tilting wheel. Same locking knob set up in the middle. But when you turn that one, it tilts the blade. And if you could look inside the machine, you see everything is swinging off to the side. The motor, there's a whole carriage underneath it that tilts. And usually a saw will tilt to one side or the other only. It'll go all the way to 45 and stop, but it will only tilt usually in one direction. I've never seen a saw tilt both ways. Okay. If you do use the saw, it's always best when you're done to put it back to 90 so that the next person that comes up to use the saw, they're ready to go, because usually the vertical 90 degree position is where you want to have it all the time. We can put on here different guards and the like. This is called a throat plate. Okay, the throat plate is what you would take off to access inside here. And if I'm going to reach in here to change a blade or anything, I want to make sure it's unplugged. And our machine plugs in way down here. So before I stick my hands in there, I'm going to unplug this. Okay, and then down inside, I could put in a riving knife or a guard, and the blade. While we're talking here, this currently has a dado blade on here. So we're going to be using a regular blade. So let's show you how to change a blade and take that off while we're talking about the parts. All right. Underneath here we have the wrenches. I find it easiest to raise the blade all the way up when I change the blade. Just makes it easier. The wrench has two ends to it. One end has got a box end and an open end wrench. The open end is for the side closest to the machine here. And there's two little flat spots on the arbor that will hold that still. Some machines don't have this. In that case, you'd have to jam a piece of wood in here into the teeth of the blade to hold the blade steady as you undo it, but it's nice when it still has this. Excuse me. Then the box end of the wrench goes on the nut. Hook it onto the nut and just pull it towards you to loosen it. And again, the power is off when you're doing this. And then carefully take the nut off. Now be careful to not drop the nut down the inside the machine. It'll either fall into where all the sawdust is down at the bottom, or our machine has a sawdust collector hooked up to it. So the pipe goes out the back and there's an elbow there. You can pull the elbow off and retrieve the bolt from there if that happens. And there's also a washer on here. Sometimes you use the washer with the dado blade, sometimes you don't. Carefully remove that as well. And then take off the blades. Now there is a little door in here that you can open. It's held shut with a magnet. Just makes life a little easier reaching in there. As you take the blade out, be careful to not bang the teeth into the metal opening of the saw, because it will chip your teeth on your saw blade. This has a little chipper in between here. We got to take that out. That here, and then the other blade. Now, we have a little box here that we keep our dado set in. Here's the cartridge that I was talking about. I'll talk about that in a second. You want to, actually, let's talk about it right now. We want to take out the cartridge. There's a different cartridge for the dado set than a regular blade. To take the cartridge out, there's a little red lever here. I don't know if it can be seen from there. My cameraman might want to come around and take a look from the other side, but I'll point to it. See that red latch down there? Yep. Get my hand out of the way so maybe you can zoom in on it a little bit. It's in the dark. There it is. Okay, we're going to turn that so it's pointing towards us and pull it out. All right, that's what holds the cartridge in place, and then we have to wiggle the cartridge out. Just got to wiggle it back and forth. It's on two posts and slide it out. Okay, and it's got a little computer connector there that brings it in and connects it to the computer inside the machine, which we'll talk about in a little bit. You can tell the cartridge for the dado set compared to the regular one because the dado blade can be fat, so it's a fatter area on the cartridge brake portion, where a regular blade is skinny just because it's one single blade. This one also sits a little taller, but that's harder to see. But the main thing to look at is the thickness or the width of the cartridge. Okay, so we're going to switch to the regular one. It's easiest to switch cartridges with the blade off. Okay, now down inside of there are two posts that sit on. One's going to fit in this hole, and one will fit in this hole. And the hole for the key is right here. So when you're down in there, you can't really see this, but this key will fit in here. It's between these two holes. So once it's down in there, what I usually do when I'm holding the key, I kind of reach in there and feel around for that hole, and then I know where to put the key in when I do that. So you're going to plug it in so that the plug is facing in towards the machine. Put your finger through the big hole. It makes it easier to hold on to. And then drop it down in there. Get the bottom one lined up, and then the top post is right underneath this clamp for the fence, for the guard rather. Push it in all the way. Make sure it's in. Take the key. Put it in, and then turn it all the way down. Now here's another little thing. You want to make sure that that's all the way down, so push it down real good, because if it's up just a little bit, the saw knows, and it won't start with that up, then you'll have to open it all the way up again and get your hand in here to push it down all the way. So make sure that that red arm is rotated all the way down. Okay. What happens when this thing fires? Well, I can show you when that has happened on. But there's a spring in here and a fusible link, and when it senses your finger, the fusible link releases, and this aluminum block slams up into the blade and stops it. It's really cool. But we have this little box here that we have everything stored in, so let's put that away first. Never lay a blade, by the way, down on a steel table, because it will chip the nice sharp teeth. So put them into your case there, or wherever you keep your blade stored, put that away. Okay, and then the throat plate for a regular blade is different than a dado blade. The dado blade had this wide throat plate. Use the narrow or regular throat plate with a regular blade. Let me show you what happens when a cartridge fires. I have one in here. This one is fired. And see how the blade buried itself into that aluminum? And the whole carriage of the blade, the arbor, and everything drops out of sight when this happens. It happens in like milliseconds. It's really, really a cool thing. It's kind of like an airbag going off in a car. It happens that fast. But anyway, so back to our setup here. We're going to put a blade back on here. When you put a blade on the machine, first put your cartridge in, then put the blade with the teeth pointing towards the operator. Again, be careful as you put it in here so you don't ding up the teeth. Then take the washer, broadside against the blade. Put that in there, and then put the nut on. Try not to drop it down the chute. Snug that up. And then when you tighten it up, don't make it super tight. Just like that, and that's plenty. It'll tighten more as the machine's running because of the way it spins. It tends to tighten the bolt more. If you over tighten it at the beginning, when you go to take it off, you're going to have a hard time. So that's putting a blade on. Now, whenever there's a regular blade on the machine, you want to have something behind it. That's the rule. So if it's a dado blade, nothing behind it. No riving knife or guard, because they'll be in the way. But with a regular blade, you can have a guard or a riving knife. And here are the two different things that I'm talking about. They hang on this machine. They hang up underneath. And this is the guard. Let me put that on first. And it has a couple of kickback pawls on the side here. When you put it in place, pull those all up and have the lid up like this. And if you hold it like this, that gets everything out of your way. And you're going to place it right down in here. And these 4 holes will engage into 4 pins that are inside of here. And then when you push this lever down, there's a lever right here, if you didn't see it, that clamps everything in place, right? And then I'll just slide the guard in place as well. Now, one thing about the throat plate rather. The throat plate has 2 little buttons here that have to kind of seat underneath these buttons. If they're on top, it doesn't sit right. I'll show you what I mean by that. So you can see how this is sticking up a little bit. It's because those 2 buttons are one on top of the other, but they have to hook one under the other. So to do that, just pull up this end, pull it back a little bit, it'll drop under, and it'll click back in place, and now it's flush. So whenever you put a throat plate in, always make sure the back comes up flush, that it's not sticking up in the air, so it doesn't screw things up. So that's a regular blade with a guard and splitter in place. Now this is called a splitter, or some people call it a riving knife. I tend to call this a guard and splitter, and I call this a riving knife, but a splitter and a riving knife are the same thing. This is basically the same setup, only without the guard. So this splitter is a little bit thinner than the blade by a very, very small amount. Basically, it's essentially the same thickness for the most part. What happens is when you're making a cut, if the board wanted to close in on the blade, it would close in on the splitter or riving knife and not the blade. If it closed in on the blade, it's going to grab the blade which is spinning and throw it back at you. But if the splitter is there, it'll just close on the splitter. The splitter will maintain that opening so that it can't grab the blade and cause a kickback. And if it does, that's, again, a kickback is one of the things that most common cause of an injury on a table saw is a kickback. Because the board grabs the blade and it goes the way the blade's going, which is towards you, and it's lightning fast. It's so fast that it throws it back way faster than your brain can register what's going on, and it's already over before your brain says, hey, pull your hand out of the way, because it's just that fast. So sometimes you cannot use, let me lower this down a little bit here. Sometimes you can't use the garden splitter because you're making a groove. If you wanted to cut a groove in the board and the blade was only this high, let's say, let me grab a piece of wood here. We can demonstrate this. We'll simulate it anyway. So let's say I was just cutting part of the way through the wood. So I'd have a cut going on here, but when I get to about here, it's going to bang into this because this is sticking up higher than the blade. What I could use, if I was doing a groove, I could still use the riving knife, but what I would do is I put that in instead of the blade, instead of the regular guard, and the riving knife is actually just a fraction lower than the height of the blade, so that if I was making a groove, the riving knife can go in the groove and not be in the way. Now, the board's not going to close in on the blade if you're just making a groove, because there's other wood there, obviously. But the secondary purpose of a riving knife is to kind of continue to guide the board in a straight line. And it, again, helps with kickbacks. If you wanted to see how, go look at my video on doing kickbacks, and I do a kickback with and without the riving knife, and you'll see that difference right away. But it's always good to have a riving knife behind the blade. Okay, but the main purpose of it is to keep it from binding on the saw blade. That's the main purpose. And if you're taking my test, that's a test question. Just telling you, the splitter or riving knife prevents the wood from binding on the blade, but it does help in other things too. So if you have a regular blade, it should have one or the other in place when you're using the machine. Okay, so we talked about a few things here. I should have mentioned while I had this open, this threaded shaft that we put the blade on is called the arbor. You want to know the diameter of your arbor, because whenever you buy a blade, you want to buy a blade that has the right size arbor hole in it. We have a 5/8 arbor on this saw, so when I buy blades, I always make sure that I have a 5/8 arbor hole on the blade. That's a pretty common size, but you should know that on your own saw. So going down our list of parts, we talked about the table, the base, the miter gauge, the rip fence, the garden splitter or riving knife. And again, riving knife and splitter is really the same thing. Throat plate, the hand wheel in the front, which raises and lowers the blade, the tilting wheel on the side, which tilts the blade. And now let's talk about the power button, which is the last thing. And again, on this particular saw, it's a little different than a regular saw. On a regular saw, if I had it plugged in, I just have an on-off switch. Okay? Sometimes they have a paddle. But because this machine has a computer in it, it's got a switch that turns power onto the computer, and then a second switch to turn the blade on. So let me plug it back in, and I'll show you how that works. So powering the saw back up, so that I have power to the saw, but it's still off. And also, we don't use this switch much, but on the side here is a master power switch on these saws. We always leave that in the on position and use the plug to turn it on and off. But this switch here brings power to the computer part of the machine. Now, it doesn't start the blade spinning, but it's going to go through this startup sequence where the green light comes on and the red light will blink. You have to wait for the red light to stop blinking, so it teaches you patience while you're doing this. Then once the red light stops blinking, now I can run the machine. So let me get this board out of the way here. If I pull this paddle out, that starts the blade spinning, right? Push the paddle in and turns it off. Now, the reason it's a paddle is because if you're in the middle of a cut and something goes wrong and you don't want to let go to turn the machine off, you can just bump it with your knee and turn it off. Sometimes you'll do that by accident. If that happens by accident, let the machine stop, take the board out, then you can start it back up again and redo the cut. But that's how this works. Now with that light on, there's power to the machine, and all you got to do is pull this out to turn it on. So you got to be aware of that. Now I'm going to do something I don't recommend you do, but I just want to show you this. With the power on, you can see that the saw can pick up the sensing of you touching the blade, because as soon as I touch the blade, that red light will come on. So watch, as soon as I touch it, see that red light come on? So it knows I'm touching the blade. Crazy, huh? So that's how it indicates that. Now if that blade was spinning and I would have touched it, it would have fired that brake. So, we want to not do that. It's very expensive. When that happens, you lose the blade and you lose the cartridge. So it's about a $150, $200 oops. But you go home with 10 fingers. So my fingers are worth way more than $200. So don't play with that. If you cause it to fire because you were playing with it, you'll probably be responsible for replacing the cartridge and the blade. But that's how that works. It's kind of cool. So I'm going to turn that off for right now. So we have this set up just with a regular blade and a riving knife, and we went through all the parts of the machine. Let's talk a little bit about safety. Let's talk a lot about safety, because that's really important with this machine. All right. So on our handout, we're going to turn to the page on all the safety rules. And the first one, it says, use all the guards except when the blade's covered by the work. Now, if I am making a groove like I was showing you before, I cannot use the guard because it's in the way. So in that case, I just got to be extra careful. Use push sticks and know that I have no guard in here. But in that case, also the blade is very low because I'm only making a groove. But if I'm cutting all the way through the board for a regular cross cut or a regular rip cut, I want to have the guard on, not just the riving knife. Again, test question. Little hint there. All right. So if I'm making a regular cross cut or rip cut where I'm cutting clear through the board, riving knife with the guard on. Okay. That's important. Again, when you're using a dado blade, you cannot use a guard because it would be in the way. They do make some other kinds of guards that work with dado blades. We don't have that kind here, but they do make a few things that allow you to have a guard over work when you're making a groove or a shallow cut like that. Always use a guide to cut by. Never cut freehand. I would not take a piece of wood and just freehand it through the saw like this, because in the process I could slightly twist it one way or the other, and it doesn't take much of a curve to cause a pretty serious kickback. Right? I always want to have the board either against the fence or with a miter gauge for cross cutting. Never cut freehand. I can cut freehand all day long on a bandsaw because it's designed to cut curves. This is not designed to cut curves. Very dangerous. You always have to have some kind of a guide when you're cutting on a table saw. Miter gauge or fence or some other fixture that guides the board in a straight line. Again, we have a note here that not to cut rough lumber on a table saw. There are better places to cut rough lumber. This should not be the place that you come to cut rough lumber because it could wobble and kick back. Be sure no one is standing in line with the blade. Again, like we talked about on other machines, there's a kickback zone. The blade turns in this direction, so if it throws something, it's going to throw it this way. So this is the danger zone. Make sure nobody's behind you when you're operating the table saw. And try not to get behind the board if you can help it when operating the table saw. Sometimes that's unavoidable, but you try your hardest to not be behind the blade or the board when you're cutting. Saw blade height. I suggest you do not have the blade any higher than 1/4 of an inch, which is about the height of a tooth of the blade. All right? It's not going to cut any better this way than it would with it down here. Why have all that blade sticking up in the air that you can bump into with your hand if you don't need it? All right? It's going to cut perfectly fine here. The blade's coming up high enough to clear any chips, and it's going to cut well, and it's low enough so that if something happened, your hand went over the blade, you're a lot less likely to bump into it. I had a student once actually have a kickback. He was doing something wrong. I happened to look up just as he was doing it. The board kicked out, and it yanked his hand right across the blade. But fortunately, he had the blade low, and his hand missed it. He was turned white as a ghost and had to look down and count his fingers, but he was fortunate because he had it low enough that his hand cleared the blade and didn't hit it. But if he had it sticking way up in the air, he, to this day, would be missing fingers. So you avoided injury by having it low enough. So no higher than 1/4 of an inch on the saw. Never reach over or near the blade when the saw is running. So you don't want to be reaching way over the board and doing one of these things when you're operating on the table saw with that blade spinning, right? We have 2 table saws here. This one is really nicely set up for cross cutting. It's got a long fence on either table on either side. This saw over here is nicely set up for ripping because we have a long table off the back side, so when I make a rip cut, I can push the board onto the back table and not worry about it falling on the floor or trying to reach way over the machine. Now you can do it on this machine, but it's just nice to have somebody catching for you in that situation, or you can do smaller pieces. But these machines you can do either kind of a cut either place, but it's easier to cross cut here and easier to rip there, just because of the way we have them set up. Unplug the machine whenever your hands are near the blade, with things like changing the blade, measuring against the blade, or putting on or off the guard. Never have your hands down in that cavity with it plugged in. That's a definite. Never attempt to make a cut by going backwards over the blade. Now, if you have a riving knife or a splitter on there, you can't do that. But I heard a story of a student once in another school this happened. He was doing a dado cut with the blade that we just took off. He, for some reason, decided to make a cut going backwards, and he was standing on the back side of the saw and pushed the board this way for what he was doing. And he had some idea in his head that was wrong, and he never asked the teacher. And when he got to here, the board wanted to go the same way the blade was going. That's why we feed into a blade, by the way. On almost every machine that I can think of, the blade's pushing this way, you push this way, that gives you control. As soon as you try to go the same way the blade's going, the board wants to go as fast as the blade's going, and that's what happened. The student was pushing the board through this way. When he got into the wood, it took a piece of wood and sucked it through the machine, and his hand came down on the spinning dado blade and just scooped out the whole bottom of his hand. It was extremely gross. Every time I think of it, it gives me the willies. But because he was trying to feed the wrong way. Always, always, always feed against the rotation of the blade. Okay, so that's important. That's why that safety rule is in there, by the way. When making rip cuts, now a rip cut is cutting with the grain, okay? And when you're doing that, you're going to be using the rip fence to make that kind of a cut. So we have a few safety rules when rip cutting. Never pull the board backwards past the blade after making the cut. So if I was making a rip cut, when I get to here, don't try to pull the board back through again. Push it through and then either let it fall to the floor, somebody catch it, or push it onto the outfeed table there. But don't try to pull it back through the blade. All right, that's when accidents happen. Plus, even if no accidents happen, you're going to get another set of saw marks on there that you're going to have to sand out. The less you run it past the blade, the better. Always use a push stick when making narrow cuts 2 inches or less, or when there's not a reasonable safety margin for your hands. So here's what 2 inches looks like. So, by the way, the scale on this fence on our saw is accurate. So you can, I usually use the scale to set the saw up, and then I double check it with my ruler. But if I was cutting, I'm not going to want to run my fingers in that little space there, because if something went wrong, my fingers are just too close to the cutter head. So I would use a push stick to push the wood through, not my hands. Okay. Now, 2.5 inches, does that make a big difference? Probably not. But I like to use a push stick whenever I can. If I feel my hands are at all in a dangerous spot, I'm going to use a push stick. But definitely 2 inches or less, you must use a push stick. Don't leave the wood between the blade and the fence after making the cut. Now again, let's just simulate this a little bit. So let's say I'm making a rip cut. When I get to about here, the cut is completed. This piece is now separated from the piece I'm cutting, but my board is still next to the blade and the blade is spinning, so it's safer to push the blade until it gets past the spinning blade before you let go of it. It's just, again, prevents any chance of the board coming back at you. Okay, so those are some things specific to rip cutting. And then number 10 has to do with anything, cross-cutting or ripping. Never let go of the board when you're in the middle of a cut. If something has happened and the board gets stuck or something, it won't move, don't totally let go of it. You can let go with one hand while holding it and turn it off, or on our saws, all you gotta do is bump it with your knee and turn it off and let it stop spinning before you let go and figure out what the issue is. Okay, so don't let go of a board while making a cut. Always make sure the proper throat plate is in place, that we got the regular blade, so we have the proper throat plate for this as opposed to the dado blade throat plate. Never operate it without a throat plate. Right? That's just scary. I wouldn't want to operate it that way. So you make sure the throat plate's in there, and make sure again that it's flush in the back. Okay. Again, ask the teacher's permission before you use the machine, and ask for assistance from me, the teacher, before you run the machine, especially if you have a question. Mr. Chick, is this right? Did I do this right? Or I forget how to set this up for a crosscut. Can you show me that again? More than happy to help you with it. Don't guess, don't ask somebody else. They may accidentally give you wrong information that could cause an injury or maybe just screw up your project. So always get advice from the teacher. That's important. Again, always ask permission before you run the machine. Whenever a machine goes on, I should know who's there because they just told me about it. Even if you're 100% confident what you're doing, you're ready to go, hey, Mr. Chick, I'm at the table saw. That gives me a chance to look up and see what you're doing, and I know who's here, okay? When you're finished, turn off the machine, lower the blade down below the table, okay? And leave the machine, put stuff away so that it's ready for the next person, okay? And make sure the power, on these saws, make sure the power switch is off so there's no chance of the machine coming on by accident. So that's the safety on the table saw. Basic safety rules. Okay. Now, as far as operation goes, let's talk about cross-cutting and ripping. We're going to walk over to this saw to do some rip cuts, since this machine is set up a little nicer for ripping. Same exact saw, except it's got a nice extension table off the back. Okay. So we want to cut our boards to width at this point. We have a regular blade on here with the guard on already. Let me see it again. Splitter behind it, and it's got the kickback fingers right here. By the way, these kickback fingers are spring-loaded, so when you're making the cut, when you get to them, you might have to push a little bit harder for them to get on top of the board, but just be aware that they're there, okay? And then, let's say right now, these boards are a little over 7 inches wide. Let's say I want to cut them to 6 3/4 wide. So what I'm going to do is I'm going to turn off the power, because I'm going to be touching the blade here a little bit. I'm going to set this, I use the fence. Now, by the way, our fence has 2 little windows on it. The one on the left is actually for a little bit of ruler on the left side of the blade. This fence could go on the left side of the blade, so you'd use this if you're looking at this ruler. But we almost always have it to the right side, so use this one here. I put a little X through there with a Sharpie so that you don't accidentally look in that one. But I wanted to do this at 6 3/4, I think I just said. So I'm going to put that at 6 3/4, clamp it down. And I find that if when you clamp it, it straightens out, and sometimes it goes off the line. And if you push it from here, when you clamp it, it just comes back to where it was. You're best off tapping it left and right at the base of the fence to make those adjustments. Once I have it good there, I'm going to check my measurement with a tape measure or a ruler in between. So 6 3/4 should be right to the inside of the blade here. So here's 6 3/4, and I'm on the inside of the blade. So in other words, the space between the fence and the blade is what the measurement on the scale is going to be. And the piece that I want is what's going to go between here. The piece on the left side of the blade is going to be my scrap. So the piece I want should be going between the blade and the fence whenever I'm doing a rip cut. In most cases, 99% of the time, that's how you're going to set it up. Okay? And again, I'm measuring to the side of the blade closest to the fence, not the middle of the blade or the outside of the blade, but the side closest to the fence. Okay? So that checks, that looks good. And then the other thing I got to remember is I want my good edge against the fence, not the rough edge. So when I cut this to width, the good edge is here, I'm cutting off the rough side. Now, if you looked at my video on the joiner, I had mentioned that sometimes people, when they're at the joiner, they'll joint both edges, which is kind of a waste of time, because if this was jointed, like if this was a second jointed edge, what's going to happen to it right now? It's going to get cut off and thrown away. So why bother? So when you're at the jointer, you only do one face and one edge, because this is where the second edge comes. Now, another thing to realize about the table saw, it leaves a finished cut. The bandsaw will also cut a straight cut. It has a fence and an accurate blade on it. And I can cut an accurate cut on the bandsaw, but the surface is very rough. It's not a finished surface. Here, the table saw, especially with the blades that we have, leave a finished cut. So you would want to do your finished cutting on the table saw for that reason. I want to make sure my blade is how high above? 1/4 inch. So that looks pretty good, about a tooth. So I'm going to get my push sticks out. And what I like to do is use 2 push sticks. Now sometimes when you push this through, if you have the push stick, the board sticks out past the table, Lots of announcements today. Sometimes when you push down on the board, it kind of tips up. Now, this push stick is big enough that I can hold it down and do it. But if it was a longer board, what I would do is I'd put the push stick here, push the board with my hand until I'm over the table. While I'm holding it with my other push stick, I could let go and grab the bigger push stick and push it through the rest of the way. I'll do one of each so you can see how that works. So I'm going to put the guard down, and then we'll put this back on. I already flipped the switch on, so when I plug it in, the power should come on over there. So we'll let the red light blink until it's happy. There we go. By the way, this will blink in different patterns if something's wrong. Sometimes, for example, if this paddle is out when you flip the power on, it does that. It goes bananas. And you can look on the side, there's a little chart that tells you what the different blinking patterns mean. So what you can do is rectify that. If the lever that holds the cartridge in place isn't pushed down all the way, it'll have a particular blinking pattern. If one of the doors are open, there's all these little things that'll happen. So, all right, so this is ready to go. Turn the power on. I'm going to hold it tight here. This one I'm going to use my hand and then finish the cut with that. So, and I walk this left-hand push stick back. I don't let it get next to the blade. So now that I'm over the table, I'm holding it with this hand, grab the push stick, and I put it in the middle of the space and push it through. And I'm just letting this back push stick finish. And I can finish the cut with one hand. Right? Now this remaining piece that's left in there isn't really a thread of a kickback. It's stuck next to the kickback finger didn't get on top of it because it was so narrow. But the chances of that kicking back are very, very low because it's not really stuck between anything. It's just in here. But I'm not going to go after it until the power's off and the blade stops spinning. Okay? So let's do the next one. This one I'll do totally with the push stick. Again, I'm going to have my good edge against the fence, and this is a rough edge. It might be hard to see on the camera there, but that is a bandsawed edge, so it's rough. So I'm going to turn this on. So here I can, again, this push stick is just about long enough that I can hold it on there, so I can do it all at once. And again, notice how in my left hand I just keep walking it backwards, then I finish the cut without it. And I push it all the way through. Now, another point to make is a lot of people don't have a problem reaching behind the saw to grab scrap and that kind of stuff. But actually, your hand is more, let me open this up so I can explain. Your hand is more in danger here than it is here. And the reason is the blade's spinning this way. So if it kicks the board out, it's going to throw it this way. So if my hands are here and the board kicks, it's going to throw my hands away from the blade. If my hand is here and the board kicks, it's going to throw my hands into the blade. And that's how accidents happen. I know somebody who was doing a cut and they were actually using a push stick and they were making a narrow cut. The board was close and they had a push stick and they actually had the push stick on the outside of the blade and there was a little piece that was flopping around, so they put their finger here to kind of hold that piece down, and they were using a push stick with the other hand. And then that piece kicked out and their finger did this, and it went by and it just bounced off the tip of the spinning blade and it cut their finger down into the bone here. And they got a pretty nasty injury. They had to go to the hospital, I don't know if they got stitches because there was nothing to stitch. It really just took the tip of their finger and ripped it off. But got a pretty nasty injury. And they were using a push stick, and they just thought subconsciously maybe that beyond the blade, they were already past the blade, so they were safe. But that was the worst place to be. If they were holding it here and it kicked, it would have pushed their finger away. But this is the danger area, back here. So you've got to be conscious of that and think about the mechanics of what's happening. When the board kicks out, the reason people get injured on a table saw most of the time is because their hand gets yanked into the blade from a kickback. So that's what you got to be careful of. Very rarely do people just run their hand into the saw. I'm sure it happens, but that's less frequent than the kickback situation where the board pulls their hand into the blade in an unexpected situation. So that's cross-cutting. or ripping rather, I'm sorry. So now we're going to try cross-cutting. Now I can do cross-cutting here. Let me demonstrate it on this saw, just to show you. And the normal method is with a miter gauge. Okay. And I'm going to put my good edge, and at this point now I have two good edges, so it doesn't really matter if I do it this way or this way, because both edges are now good. But if I only had one good edge, I want to have the good edge against the miter gauge. And let's say this is my cut right here. I want to cut here, and this side of the line is going to be scrap. Let me get a tri-square real quick, and we'll throw a line so it's a little bit more visible. So if I had a line here, so that, let's say that's what I wanted to cut. This is going to be my scrap out here. Okay, I'm going to line this up, and the cameraman might want to get on the back here so he can see, just as I'm looking, that if you look right straight down this way, you can see how the inside of the blade lines up with the cut. So in other words, the blade is going to be cutting in this area. So I'm cutting on the scrap side of the line. If I put the line on the middle of the blade, I'm going to make the board shorter than I want it to be, because some of the wood is going to come off. And of course, if I put it on the wrong side of the blade, it's really going to cut shorter. So you want to sight right down the side there and line it up so that the side of the blade that's on the side where the good wood is lining up on the line, so the blade itself is on the scrap side of the line. That's important. So what I do is I line it up with it off, pull it back a little bit, and close the blade. Now before I can cut my board to length though, I need a good end. Neither end has been trimmed yet. So I really can't even get to the point where I can draw a line and cut to length. So let's flip it over and make believe we didn't do that yet. I want to square one end. I always want to square my best end on the board. Now, you got to look at your piece of wood and make an evaluation. So let's say I was using this one. This is a good example. This board has a little bit of pith showing here that I don't want too much of that in my project. So this is my worst end, this is my better end. And you would think to yourself, all right, what end do I want to cut off first? So your reaction might be to cut off the bad end first. But the question is, how much do I cut off? Now I cut these a good inch or so longer than I need, so I can estimate, but I really don't know. So my first end, I really want to do my better end first and take off as little as I can get away with. That way, when I come back to cut it to length, I'm cutting the most off. So you're cutting the most off on the second cut. So the first cut is usually your good end. So I'm going to flip this up and then just adjust this so I'm taking off just a little bit. Okay. Now I'm assuming my miter gauge is cutting 90. We'll talk about that in a minute. So I'm going to turn this on. And when I make a cross cut, I'm using a miter gauge. Right? I have the wood tight up against here. Make sure I don't have any fingers sticking out past the miter gauge. And I'm holding it tight in, and I'm not going to let it slide left or right as I make the cut. And then when I get to here, I like to pull the board left and come back without the board in place. Again, I don't want to run the board past the blade more than I have to. Okay? That gives me a clean end. Now, often what and I didn't neglected to show you this, but usually what I do is I put a little scribble on both ends of the board. And that way, and I do that on all my pieces of wood, so when I square one end, it's really obvious which one is the square end because that's the end without the pencil line. Okay. Now, sometimes it's really rough and you can tell, but it's better if you just put a scribble on either end. It's a good habit to get into. So now I have a good end. Now I can measure and cut my boards to length. Okay. Now that's one way to do it, and that's this machine. And that with a regular miter gauge. But if we go back to the other table saw, we have kind of a neat attachment for that saw. It's called a sliding table. Really nice for cross-cutting. By the way, when you cross-cut, you do not use a fence. Do not use the fence and a miter gauge together when you're cutting all the way through the board. Now, that's a really important rule to remember. And the reason is, let me just quickly show you that before I get into my sliding fence situation here. So let's say I was using the miter gauge to make a cut. Right? And let's say I had to cut a whole bunch of boards 3 inches long, right? So if I set my fence to 3 inches, it seems like a really great idea. Now I got to cut 25 pieces 3 inches long. I can just keep sliding it down and lopping off pieces. It sounds like a great idea. But what happens is, once I cut through here, this board is guided by the miter gauge. But once I cut through, now this piece is loose, rattling around between the blade and the fence, unguided. And if it tilts even a little bit, it's going to catch the backside of the blade and kick back pretty hard and fast. So it's a pretty dangerous situation. If I'm making a groove, let's say the blade is low and I'm just making a groove, this is okay. This is the exception. If you're not cutting all the way through, you can use the two together. It's commonly done in joinery because this is still attached to the board that's guided by the miter gauge. So that's an okay thing to do, provided the fence is not real far away. Usually when you're doing this kind of an operation, you're pretty close because it's some kind of a joint near the end of a board. But this is safe. Miter gauge and fence, not cutting all the way through because this piece is never going to get totally cut off. It's just getting a groove cut on the bottom. But if I was cutting all the way through, that would not be okay to do. You don't want to do that, okay? So don't use the two together. So when you're cross-cutting, usually your fence is out of the way and you're using just your miter gauge. Now, for change, instead of the miter gauge, we have this other thing, and it is a miter gauge, but it looks like a fence. And it attaches, make sure my power's off. It attaches to this sliding fence. Now right now this is not moving, but if you look underneath, there's this brass knob that is a lock. If I take it out and turn it 90 degrees, okay, now this will roll, okay? And I'm going to attach these two black knobs here will screw into these two holes here, okay, and become a giant miter gauge. It's awesome. So the trick with this is get one started and don't tighten it all the way down until you get the second one in there. Okay, and once the two are engaged, then you can go ahead and tighten them up. So that's the black knobs. That attaches the red miter gauge fence to the table. And then these brass knobs allow you to slide things around. Oops, get that out of the way. So this can slide, and we usually have it all the way over. We have a little stop on there. So tighten those up so everything is secure. This is a stop, which we'll talk about in a second. But now I've got a miter gauge. But the difference between this miter gauge and the one I was using before is this one's huge, right? So I've got plenty of surface area that the board is against. Now I'm going to make this cut with the guard off so you can see. Again, for a through cut you should use the guard, but for just demonstration purposes I'm going to do it without. This is the board that has the crummy end. So let's make believe this board hasn't been squared yet. So I'm going to put a pencil line on both ends, and I'm going to do it to all my boards, because that's usually what I do. Just put a pencil line on every end, so you know that if there's a pencil line there, it has not yet been squared. So I'm going to take my better end, line it up with the blade, back it up, and you can see the whole table rolls with this. This is really nice. Put the power on. And then I'm going to square one end on all three boards. So the squaring process that we use is face, edge, end, end. That's the order that we're doing it in. Face, edge on the joiner, face on the planer, edge on the table saw, and end also on the table saw. Or you could use a chop saw as well. So, here we go. Square one end. And again, when I get to here, I'm going to back it out and come back without going down the side of the blade. So that is now squared. There's no more pencil line there. I'm going to do that for my other end. Now, these boards, one end or the other, are the same. So it doesn't really matter which one I'm trimming. Just pick one. Square up that end. So now I have one good end on every piece. Stop spinning before we do anything else. Okay, so then I'm going to turn the power off. I like to turn the power off whenever I'm doing any setup. It just prevents any accident. And I'm going to get all my boards with the good ends facing the same way so I don't accidentally pick it up backwards. And let's say that I have to cut these boards to 16.5 long. So now that I have one square end, now I can measure the length. So I'm going to come over here. Whoops. Measure down 16.5. Drop my pencil once or twice. I'm going to go for another one. Make a little accurate mark. Notice I'm working with a sharp pencil. Make sure your pencil is sharp. Okay, double check my measurements, 16.5. And I put a little flag on the mark. And the reason is if I just did a little teeny dot, there's lots of little dots on my board. And I could turn away to get something and come back to the wrong dot. But by putting a flag on there, I know what mark I'm looking at. And then I'm going to get my square again. give myself a line. Right? And if I wanted to, I can even bring that line around to the edge, because that's where I'm going to line it up to the blade. And the square helps me keep the line accurate. If I just use a ruler, that line could be crooked, but the square, because of the handle of the square is 90 to the blade, it keeps the blade 90 degrees to the edge. So that's the only way to get an accurate line. So don't draw this line with just a loose ruler. Make sure you're using a square. Okay? And again, I wrapped it around the front if I want it to be super accurate. And notice I only did it to one board, because what I'm going to do is, if I'm cutting multiple boards, if I did this on every board, I'd have to line up every board. It takes a lot of time, and maybe one board I cut on the line, another one I cut next to the line. I want them all to be exactly the same. So what I can do with the power off, I'm lining it up so that, again, the blade is going to be on the scrap side of the line. That's where I want to make my cut. But I'm going to flip this stop over and slide it down up against my board and tighten this down. And then now, every time I bring the board up against it, it's going to cut on my line. Now, sometimes this has a little bit of play in it. I like to actually sometimes use a piece of scrap wood as a stop. If you don't have the fancy schmancy fence, you can do this with a regular miter gauge. What you can do with a miter gauge, because most of us don't have the money to buy these fancy fences. If I took a regular miter gauge and took a piece of wood and screwed it to here, I now have a long miter gauge, just kind of like this, and it gives me something I can clamp a stop block on, right? So you could turn your regular miter gauge into something like this for next to nothing, instead of spending, I don't know, a couple $100 for the fancy fence. But if I get a clamp and a piece of scrap wood, I kind of like this method. It's a little bit more foolproof. Put it, my board's still lined up. Yeah, looks pretty good. Put this up against there. I'm going to clamp this piece of wood onto my fence, and then double check it, of course. Pick it up against it. That looks pretty good. Oh, no, I'm a little long. The advantage of bringing that line around the corner, it allows you to line it right up with the blade. That looks pretty good. Okay, so I only drew a line on one board because I'm setting it up with that. Notice, by the way, when we did the rip cut, we didn't need a line on the board because we were setting the fence up. But here, you need a line at least for one cut, right? Once you have that set, again, I would have a guard on. Okay, but again, I want you to just be able to see what's going on here. Turn the power on once it's awake. You can see I'm cutting on the scrap side of the line. Now here, with the stop block, I have no choice but to bring it back, but everything's pretty secure, so I'm not too concerned about kickback. It's very tempting to go after that piece of wood with my fingers. You twist it. Now, make sure your good end is against your stop block. It's very easy to pick it up, put the wrong end against the stop block, and cut off the wrong end. That's not my good end, there's a scribble. There's my good end, no scribble. And there we go. I've got 3 boards, all cut to the exact same size. Same width, same length, perfectly the same. I use a stop block when I'm cutting 2 or more pieces the same size. If you're just cutting one, I don't bother with the stop block. But if I'm cutting multiple pieces, definitely a stop block. 2 or more, because it's almost more important that they're the same than that they match your measurement. If I'm a fraction over or under the measurement, sometimes that's not so bad, as long as all the pieces are exactly the same. Try for accuracy, of course, but that's the best thing. Now again, when you're done, you're going to turn off the power, lower the blade, and leave the machine clean for the next guy. Now, let's just do a quick review here. Okay, so for cross cutting, I'm going to use a miter gauge, no fence. I can use a stop block for multiple pieces. When I'm ripping, I'm going to use the fence, no miter gauge, and I don't even need a line on the board because I can set the fence to exactly what I want. right? And I'm ripping the piece that I want between the blade and the fence. The scrap is on the outside. When I'm cross cutting, all right, I want to be cutting on the scrap side of the line. Okay. The only time I can use the miter gauge and the fence together is when I'm doing joinery, where I'm not cutting all the way through the board. I do not have a loose piece of wood. That's really important. Okay. Again, on the handout, there are pictures showing you all the things that we just talked about. Showing a cross cut and a rip cut. Make sure you understand the difference between those two. And safety and all the parts and everything is right here. There's a lot more to know about the table saw. This is the basics. There are some exceptions and different things you can do, especially when doing joinery, but we'll cover those at a different point in time. But this is the basics on how to use the table saw. Hope you learned a lot.